So first, we have the definition of a system. We reviewed this yesterday. What is a system?
Two equations.
Yep, two equations, two or more equations. It could be inequalities, but for this we'll just say equations. And by equations, I mean lines. Okay? What does the solution look like?
It's the x and y.
Yeah, it's the xy. It's the point where the lines cross. You can come back and sit over here because Maria switched classes. Yes. All right. Thank you. All right. So these two equations were given to us in the slope-intercept form, y equals mx plus b. So if you guys recall, you just have to look for the b value, which is the y-intercept. So what's the y-intercept for the first one? 4. And then we do rise over run. So we go up and to the right. So I'm going to go up 1, 2, 3, 4, 5. To the right, 1, 2, 3. Yep, I did go off the graph. And then I can do the opposite of both of those. So I can go down 1, 2, 3, 4, 5, left 1, 2, 3. Okay. And then I can go ahead and draw the line. And lines continue forever. So I'm going to make sure that I have arrows on both ends. Maybe I should fold this. Okay. The other one, we're going to start where? -2. Okay. The top number tells me to do what? We got a negative in front of the fraction. Go down. So I'm going to go down 1. The bottom number always tells me to go to the right. Doesn't matter what the sign is, I always go to the right. So I'm going to go down 1 and to the right 3. Down 1 to the right 3. Down 1 to the right 3. And then when I run out of space, I can do the opposite. So up 1 to the left 3. And then draw my line. And if the solution is where they cross, then what is the solution? -3, -1. Okay. These two equations are in standard form. The x and the y are on the same side. The numbers on the right. So 4x minus y equals -2. What should I do? I want to be able to graph it.
In the slope intercept.
Mm-hmm.
So you're gonna move your y to well, it's already 5. you're going to subtract your 4x, but then, can you have a negative y?
We can right now, but then we don't want it to be negative when we actually graph it.
When you don't want it to be negative, you multiply the whole thing by -1.
Okay, so I'm going to write my 4x first because that's the order that I'm used to. So negative 4x, negative 2. And then to get rid of the negative here, we can multiply by -1 on the left and multiply by -1 on the right. And actually, let me write the right side a little bit better. I'll say take the right side and multiply by -1. There we go. Okay, so on the left, when I multiply by -1, I get y. When I multiply on the right side by -1, what do I get? Okay. So we're going to start at 2. And how do I take the whole number 4 and write it as a fraction? 4 over 1. Okay. So we're going to go up 4 over 1. Okay. All right, and then for the other one, 12x minus 3y equals 12. What should we do?
Get your line correct. So you subtract your 12x.
So the negative 3y is all alone. I'll put the x first. So negative 12x and then a positive 12. And then what should I do?
Can you have a number in front of the y?
Mm-mm.
So multiply the whole thing by -3.
Not multiply, divide. Good. Good correction. Okay, so divide by -3, divide by -3, divide by -3. So y equals positive 4x minus 4. Good catch. Okay, so we're going to start with the y-intercept of -4. And then what's our slope?
4 over 1.
Yeah. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. 2, 3, 4 over 1. Okay, so what's happening with these lines? They're parallel. So what would we say for the solution?
All solutions.
No solution, yeah. So if the solution is where they cross and they're parallel, then that would mean no solution. So solution, no solution. The reason is parallel lines. Okay. So next we're going to graph inequalities. Do you guys remember what the line part of an inequality looks like that's a little bit different from just a regular line? Anybody remember? How do inequalities look different? They can be dotted. So inequalities, when you graph the line, sometimes they're solid and sometimes they're dotted. And then what else is different? What's like the big difference in an inequality when you graph it?
since there's like a greater sign and a less than sign,
Mm-hmm.
it's like, how do I explain it? It doesn't go both ways.
Mm-hmm.
It only goes one way.
Mm-hmm. Yeah, so if we, let me pause this. Let's look at, if we have one inequality, then it shades once. If we have two inequalities, we have two types of shading, like two different colors of shading. And so the answer, it's not just where two lines cross and you get 1 point. It's where two shadings cross. So how many points do you get? A lot, right? Do you get 2 points? No, how many points do you get? They call it infinitely many because it's not necessarily like a distinct point where it's just like a nice x value and a nice y value. It's like all the decimals in between, right? All the fractions, all the decimals, all the square roots, like every number in between. So it's one shading on top of another shading. Okay, so let's finish these notes. So keep that in mind when we do the system of inequalities, is we have shading on top of other shading, and so that means our solution is no longer just 1 point written down. It's a picture. It's the picture of one shading, the picture of another shading, and where they overlap. So it has to be a picture because we could not possibly write down all the points. That would be us coming up with a lot of decimal answers. Does that make sense? Okay, so solution to a system of inequalities, we say infinitely many solutions. That just means there's a lot. Infinitely many solutions. Where two or more, because remember we could have two lines, but we could always have more lines. Or in this case, two shaded regions or more shaded regions. Two or more shaded regions or solid lines, right? Because we know that solid lines, that's the equal part, right? The equal to part. Those are where solid lines cross each other. Those are solutions. So where shaded regions or solid lines intersect. Okay, so we're going to practice this. So off to the side, we're going to make ourselves a little kind of cheat sheet here. We're going to remind ourselves that less than and greater than, this gives us dotted lines. And that less than or equal to and greater than or equal to give us solid lines. Okay, so let's go ahead and start with the first example, and we're going to graph it. It is in the standard form, so I'm going to go ahead and write it off to the side. I'm going to write it as an equation just for me to graph it, just for me to graph the line. I'll come back to the inequality when I start doing the dotted versus solid line and when I figure out the shading, but just for me to get the points down, I can do an equality, an equal sign. So if I want to graph this, what should I do to get y equals mx plus b? Yeah, subtract the 5x. Okay, let's do that. Minus 5x, minus 5x. Okay, so we have y equals negative 5x plus 2, and that one is ready to graph. So I'm going to put my y-intercept at 2. And I'm going to go ahead and go do what for my slope?
Go down 5
Over 1, okay. Okay, now I'm going to ignore this because that was just helping me get my points. I'm going to go back to the top. Based on the symbol, is this a dotted line or a solid line? It's a dotted line. Okay, so now I'm going to take my straight edge and draw a dotted line. And when we shade for inequalities, we want the shading to be where it's true. We want shading to be a point that makes it true. So you have to pick a point that's on the right side of the line or the left side of the line. It doesn't matter. Any point. A lot of people pick 0, 0 because they're lazy, and 0, 0 is easy to plug in, but it doesn't matter. You can pick any point you want. Okay? So can somebody give me a point? We're not going to do 0, 0 because I don't want us to forget why we're doing what we're doing. So we're going to pick something other than 0, 0. Okay? So somebody give me a point that is not 0, 0. It has to be on one side of the line or the other. Any point. How about 2, 5? Does that sound good? 2, 5? Okay. So 2, 5. 2, 5 is on the right side of the line. Does everyone agree with that? Okay. So I'm going to take the inequality. I'm using 2, 5, so that means 2 for the x-coordinate, 5 for the y-coordinate. So I'm going to do 5 times 2 plus the y-coordinate is less than 2. Now I have to figure out if this is true or false. True or false. This is definitely false. Okay, false. Okay, so now I'm going to say this is the point over here. This point is false. So if this side is false, then where's the true side? The other side. This is the true side. So now I'm going to shade over here. Okay? All right, I'm going to switch colors. I'm going to do a different color for the next one. The next one says a y-intercept of -5. So I'm going to go down 1, 2, 3, 4, 5, y-intercept of -5. What's my slope? Two over 1. So I'm going to go up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. Okay? I'm ignoring all the pencil that I did. Let's pick a different point. So I'm ignoring 2, 5. I'm going to use a different point this time. Anyone have a point they want to use? On either side. Say it again. 4, 2. So 4, 2 is right here. Let's go ahead and draw the line on this one. So based on the symbol, is that dotted or solid? Solid. Okay, so we'll draw that line. It's a solid line. Okay. So if you can see the point 4, 2, it's a little bit on the right side of the line. Would you guys agree with that? Okay. So now I'm going to say let's use the point 4, 2, and now I'm going to plug it into the inequality. I've got 2 for the y-coordinate is greater than or equal to 2 times the x-coordinate minus 5. So 2 is greater than or equal to 8 minus 5. 2 is greater than or equal to 3. This is false. So you have to picture that you didn't graph anything. So pretend that the pencil isn't there at all. So the false is this entire side. The true is this entire side. So I'm going to shade the whole thing. Okay. So can we see where the double shade is? Yes. So I'm looking for on mine where my red and my pencil is. That's where my solutions are. So possible solutions for this problem. A possible solution could be -6, 0. That's right here. Another solution could be -4, 3. That's in the double shade. Another solution could be this point right here because it's on the double shade and it's also on a solid line because solid lines are solutions. Dotted lines are not solutions. They do not equal, but solid lines do equal, so they are solutions. Does that make sense? Okay, so this point that's on the solid line and then on the edge of the double shade, that one works. And so that was the point 0, -5. So that's a solution. So if you wanted to see examples of the solutions, you're just looking in the double shaded area where solid lines are. Now, if I look where the solid line and the dotted line intersect, is that a solution? No, because it has a dotted line. And it's not where the double shade is. If I look at this point right here, it's where the double shade is and it's where a dotted line is on the double shade. Is that a solution? No, because it's a dotted line. So we're looking at the double shaded area where the solid lines are. Okay. Over here, the point -8, -8, this is a solution. So anything in that double shaded area is considered a solution. So these are specific examples of solutions, but if somebody wanted to see the whole solution, they need a picture for that. Does that make sense? Okay. All right, let's go ahead and draw the next one. All right, so I'm going back to my pencil for my first color. 1/2 x plus 6. Where should I start? 6. Okay. I'm going to go do what? How do I do the slope of 1/2? Okay, up 1, right 2, up 1, right 2, then go the opposite way. Okay. Based on the inequality, is that a dotted line or a solid line? Dotted. Okay. And then if we pick a point to plug in, what point should we use? 4, what did you say? 4, 2? Yep, that works. Okay. Okay, so we've got 2 for the y coordinate, 4 for the x coordinate. 2 is less than 1/2 of 4 is 2 plus 6. 2 is less than 8. True or false? True. Okay, so the point is true. That means the other side is false. And so where should we shade? True. Shade where the point is. Are we going to save the sugar gliders today? We're going to get all of our shading right? Yes. Okay. X is less than 5. We have to remember if X is less than 5, is that a vertical line or a horizontal line?
Horizontal? No.
Vertical. Yeah, it's a vertical line. I have two little posters up there for you guys to kind of help you remember. So X equals C, you can see it's a vertical line. Another way you can remember it is X equals 5 means that the X coordinate of the point has to be 5. So you can think of like 5 comma 0, 5 comma 2, 5 comma 5, 5 comma 7. If the X coordinate of the point always has to be 5, that's going to create a vertical line. Does that make sense? That's a good way to help remember it. Is that a solid line or a dotted line? Solid, okay. And we have to pick a point to plug in. Let's pick something other than 4, 2. It's got to be on one side of the line. 6, 2. Okay. So if we have 6, 2. Now, if we take this inequality, we don't have a place to plug in y, so we're not going to. We're not going to plug in a 2 because we can't. But we can plug in the x value for 6. So 6 is less than or equal to 5. True or false? False. Okay. So the red point itself is false. If this side is false, what about the other side? It's true. So that means we shade the whole thing. This whole thing is red. So we have a double shaded region now, but we're not done because we got 3 inequalities this time, so we have to keep going. Okay, so y is greater than -3. This is saying that every coordinate for this line has a y coordinate of -3. So we have the point 0, -3, -4, -3, -7, -3, 5, -3. All those have a y coordinate of -3. So we have a horizontal line. Is that horizontal line dotted or solid? Dotted. Okay. And let's pick another point to plug in. What point do you guys want to use? -5, but it can't be on the line. It's got to be on one side or the other. -5, -4. Okay. So -5, -4 is on the bottom of the line. So -5, -4. Okay. We cannot plug in the x value because there's no place to plug it in, but we can plug in the y value. We have -4 for y is greater than -3. This number is more negative. This number is less negative. Are numbers that are more negative bigger than numbers that are less negative? No, this is false. Okay. So we're going to shade the opposite way. Okay. So can you guys see the triple shaded area? Pencil, for me it's pencil, purple, and red. It's almost a triangle shape, but not quite. So what's a solution that shows up in that area of the triple shade? 2, 4. Over 2 up 4? Yeah, I believe that. I can't see it because I drew on top of it, but I think so. Does 0, 0 show up in that area?
Yes.
Yes, it does. Okay. What about right here where these lines cross? Is that a solution? No. Why not? Yeah, one of the lines is dotted. So one of them's solid, which means that it feels like it could have been an answer, but then one of them's dotted and that ruins it. Okay. Let's find a point over here that would be a good answer. So let's say like -5 what over here? -5. I think -5 is actually not. -5. -5, 3. Okay. Okay. All right. So for the rest of the period, I have you guys working on 2 assignments. One assignment is practicing graphing lines to find solutions. The other is graphing inequalities to find solutions for systems there. So both of them are finding solutions graphically for systems, okay? And then the other thing I'm going to hand out is the sheet for tonight's notes. Sound good? Okay.